So Mike couldn't be here. He had a last minute thing he needed to go to. So my name is Balki. This is Pawan. This is photos. We are PhD students under Mike Zeta, and most likely we are the people who you'll be interacting with to turn in your weekly progress or whatnot, and also for any questions and concerns you have. You can always approach Mike anytime. You can feel free to email him, schedule an appointment, and go down to him directly as well. And first things first, one-page proposal due February 7th. So this is the link to the place. It's a Google Drive folder. Just log in, put in your proposal there. Word doc, PDF doc, whatever you want. We'll also send the link to this presentation itself so you can go home, go back and review whatever you want to. Most often we have weekly meetings. We encourage weekly meetings that is mostly amongst yourselves, not necessarily always with us. With us it could be less frequent, maybe a fortnight or something. It's no good place to stand. And then at the end, finals week, some projects we have demonstration. Obviously, if this is the number of people we're going to have, it's not going to be hard to accommodate everybody, but maybe some of the flashiest and best works could be demoed here amongst each other, and the others would just be turn-ins. You write some report, or you send us a software deliverable that we can take a look at, or maybe even YouTube video clips of something that you've done. The proposal, basic info, what you plan to do, what you will learn from the directed research. So we know it's kind of a little loose here. Usually directed researchers are strictly controlled by the professor. He has something that he wants everybody to do, and that's thrust upon you. But here, we let people dabble a little bit in games and game-related technology, some software, Android apps, mobile apps, something like that. So for that, we need to make sure that you are actually tackling some kind of a new problem for you. It could be something that's been solved already by somebody else, but it should be new for you. You need to lay down the steps and tell us how you're going to approach that issue and how you're going to solve it. Okay, so for example, if you want to do something, say, voice or accelerometers and mobile apps, you need to tell us, okay, this is step 1, I'm going to learn this thing. Step 2, I need to learn this toolkit. Step 3, this is what I'm going to do. These are some of the articles or papers I'm going to read. So that's what we want you to have a roadmap of. What you'll have at the midpoint of the semester and what you'll have at the end of the semester. You can obviously vary certain things at the midpoint, and you realize you need to go a different direction, that's fine. But we want you to have a kind of an idea as to what your roadmap is going to be, what you're going to be accomplishing at the midpoint and at the end of the semester. Keep in mind that you're all going to have other classes and other exams and other stuff, so don't put it all the way to the very end, and don't overcommit yourself to something that you cannot achieve realistically. So we'll help you with the scale and the scope of your projects that you're selecting and sending to us, but also just have this in mind. Also, do not underachieve and underrepresent or underreport, because if it's a simple app that we've seen made 500 times here in previous projects and stuff, it's probably going to be not selected. Choosing your topic. So I know this room is getting a little warm. So those of you who know what you want to do, we strongly encourage you write up this document offline, send it to us by February 7th. And we strongly encourage you to work at least in team of 2 and not just individually, because you can complement each other's efforts, you can cover more ground, and we have an easier time when it comes to having 2 people prodding each other along and making sure everybody stays on track. So once you have this proposal, send it to these 2 email addresses and drop it in the Google Drive folder that we have. If you don't have a topic in mind, here we go back to what this lab, GamePipe Lab and Game Intelligence Lab and other related institutes are working on. And you can stay on here and listen to some of what we have, and you can pick something that you like from there. So those of you, at this point, those of you who already know what they want to do, can you please raise your hand? Do you have a pet project that you want to do? Some Android app, something? 1? Higher, please? No? 1? Okay. Just 1? Ooh, brutal. Okay. Is there anybody else behind you, or just the 2 of you?
I think there are.
Okay, for DR, those guys are not here for the DR, I think. Mirror Lab? Okay.
Yeah, we're here.
I'll call you. They're gonna have let's squeeze in. Alright, since everybody wants to do something that we've been working on, so broadly, these are the things that we have going on here. We have GamePipe R&D. GamePipe is our lab, USC Games GamePipe. We are kind of the engineering wing of game development at USC. We also do some R&D, elastic computing, AIRL, behavior box, satellite or Watson. We'll tell you what those are. And then we have game projects. So game projects are games that are being developed by USC students. It's their final capstone class where they show off and create these awesome projects for themselves. They sometimes often have some engineers who are leaving their teams from one semester to the other. It's a 2-semester thing. So they might need some help. It's not always engineers. Sometimes they require some artists, some sound design, whatever. So we have some people from those teams. They'll let you know what they're looking for and you can contact them. If none of this interests you, we also offer a game research seminar. That's probably the most classic form of DR. You can work with us to pick a topic and we'll research that thread throughout the course of the semester. You read some papers, write in reports and things like that. We'll have maybe monthly discussions. And then there's some miscellaneous stuff which is mostly software engineering related things or IT related things that you can also work on. But those things are kind of hard to measure what exactly you learn from those things. So you have to really sit down and dig deep if you really want to take some of those miscellaneous activities. We'll talk about it when we get there. So R&D, elastic computing projects. So recently we have some collaboration. We've had some collaboration with Electronic Arts, EA, and they want us to investigate how we can use the cloud to empower games or game-like apps. So we are looking for 4th-grade students to use Amazon's Elastic Compute 2 framework. You build a demo with a small set of AI characters. So the computation for these AI characters are being carried out in the cloud. So locally, you don't actually run any logic for how these characters behave. You just run it in the cloud, and the cloud sends you the result, and that's what you see. So this can scale easily from a mobile game to a web game, to even a full-fledged AAA title. So client running on PC. We'll stick to PC for this phase 1. This just reinforces, since we're giving you this document, we wanted to put it out in a few sentences what we're trying to do. Client real-time, latency measurements, blah, blah, blah. So part 2, so hopefully by midterm or by some point after midterm, we'll have part 1 done. And then we need to draft some architecture guidelines. So this is almost like, you come here, sit down, create your paper, write your results and send it in, so we can pass it along to the next semester of DR students who can build upon your work, or possibly even publish if something really exciting comes up from this project. And here I'll hand it over to Povin, who will talk about some of the other projects.
Yeah. So the AIRL is a project that one of our PhD, Jerry Lin, is doing, and I didn't want to do too much, so really, he's interested in using or modeling human emotions in AI, and that basically building a model based on that, and this is part of his dissertation, so it's something that you could potentially get a paper out of or something like that, but yeah. So these slides will also be shared later, so really take a look, and if you are interested, talk to him, Jerry Lin at usc.edu, and also what was it earlier? I think you were just covering elastic computing is something that Professor Zeta really want to pursue, so he's looking for team 4 to 8, just so you know. Behavior Box is another project where the project is about how you could have real life events influence something you have in a video game, so that you're really building a virtual world that some real life event, like say, what was the example you always use? When did Lohan getting drug abuse again? But yeah, something like that. So, or like say Apple just released iPad, right, the newest version or something like that. So then, what will happen is their stock is going to go up. So in the game, you will have like a avatar representing Apple. Then it will get bigger and bigger because its stock is going up, and because its stock is going up, it will also be very happy and jumping around. So that's kind of like what this project is about, just doing a proof of concept. And similarly, if Apple is in Silicon Valley and it's raining or snowing for the first time in God knows how long, then you will feature like, hey, there's a little snow on top of the Apple Cloud. This project's been done previously with like two different teams. One work on Yahoo Finance information, and the other one does like news data, news and weather. So what you would do is really pick up what they do and just like continuing polishing it and making it better and utilizing reading other data. And so yeah. Satellite Robot Sim. So the Satellite Robot Sim is to really do NASA has a project called the Phoenix Project, which is about how in the future they want to launch a robot that goes into space, uses its tools, and basically salvage from existing satellites. So you spend millions of dollars launching a satellite into space, right? And that costs a lot of money. While the computer might have been dead, but the electronics or some other parts of the satellite is still usable. So that robot would basically cut off the antenna dish and install a different microcomputer that it brings with it and make a new satellite out of it. So in the satellite robot sim, you're really trying to do like a game version of that, where you're looking like 5-10 years ahead to what potentially you could do with this project. So you would presumably be a person here on Earth piloting a robot in space and controlling it, so you have to deal with delay, you have to deal with the space physics and all that stuff. And so now we go to game projects, which is to mention the projects that students have done for other classes. So you work either with advanced game projects or other game projects, and it is up to you guys and the team to figure out what actually works for you. So in some cases, you will directly work on their game and their game engine. In other cases, maybe you'll design a website for them or something like that. So you will have to discuss with them. And we're missing a few, but the first project is going to be Mirror Lab, Social Clues, Maestro, Local Lab, and the World Building Media Lab. So we'll start with Mirror Lab. Can you guys get in here somehow? Hi. So I'm going to hand it off to Amanda.
Okay, sorry. Hi everyone, I'm Amanda, and this is Matt, and we're the team leads on Mirror Lab. My focus is more on creative, and Matt on engineering and design. So Mirror Lab is a 3D PC-based Unity game that we've been building. We're halfway through, so we already have a pretty strong demo to start off with. It's about exploring an ecosystem, solving ecosystem-related puzzles, and then moving with exploring further, discovering more within this generative world. So here's a screenshot of part of the ecosystem. You play as a jellyfish. It's based on the immortal jellyfish, and there's some sort of retro-futuristic pulp in the background.
And so one of the core gameplay elements in our game is the player's exploitation of animal AI actors that kind of come together to create a biological ecosystem. And the core gameplay is the exploitation of those ecosystems to cause state changes in the environment so that you can move forward and progress in the game. What this means is that a lot of our core gameplay elements include AI development, and in addition to the creative side of it, we have a lot of development going on in custom shaders and a lot of other rendering graphics tasks for engineering.
So here's an area where you're solving a puzzle related to these fish. You're creating a lure through releasing food particles to open up a gate to allow you to move farther within the world, and to also be able to move this current system around. Okay. So specifically, what we can talk more about the game if you guys have questions, definitely. But specifically, what we're looking for right now for engineering are gameplay engineers, specific AI. So in terms of behaviors for these different types of actors, different types of fish, sharks, eels. Do you want to say more about that?
Yeah, basically, so we have our entire framework for AI laid out, so a lot of it will be scripting new behaviors. We also have a lot of tasks for control scheme, gameplay engineering, that kind of thing. We have a lot of back-end tasks for data management, player profile, that kind of stuff is still under development. So they're really, this is kind of suggesting of some of the things that we do have a current kind of need for it. But one of the good things about our team is that it's a really strong group of engineers, and they're all pretty versatile.
Yeah,
So
almost.
we're able to really kind of move it around a lot. So if you guys are interested in something that's not specifically listed on there, we can use help in really any kind of capacity for gameplay. Well, no, I don't think we mentioned, this is actually a game in Unity 3D. So we're writing in C#, and yeah, so and the graphics are for DX9 and for OpenGL. So
Yeah, so we're really trying to push the graphics as far as we can, so we're doing a lot of custom shader implementation, shader maps and things like that. And so we have a graphics engineer who's already done some of that, but definitely that's an area of exploration that could be really interesting for someone. And then I just want to say a little bit more about the controls. So since you're this jellyfish within this underwater world, we've been continually working on developing those controls so they feel right, and so that it's easy for the player to navigate. So there are 360-degree controls with the camera right now, but that's an area that we'll continue to polish. And our guy who was working on that graduated, so we would love someone to really focus on polishing up those controls if someone's interested.
And that's kind of a common theme for a lot of the engineering positions we have, is there is not a hard barrier between design and engineering, so there will be a lot of kind of opportunity to, you know, look at gameplay design and implement it into your tasks.
Yes.
If you guys have questions, stick around and ask them about it, and we'll bring it to. Do you guys want to talk about this?
No, this
Oh,
is kind of, yeah, this is kind of what we mentioned already, but we can make the PowerPoint available if anyone wants more information, and this is our contact information. So the game is called AIRL, and